Have you ever looked out an airplane window and wondered, why is it round? At first glance, it seems like a design decision. Maybe it just looks nicer, but behind that simple curve is a tragic story, one that changed aviation forever. Because there was a time when airplane windows were square, and that small choice led to some of the most catastrophic disasters in early commercial flight. In the 1950s, jet airliners were the next big thing. The de Havilland Comet became the world's first commercial passenger jet. It flew higher, faster, and smoother than any plane before it. It also had square windows, just like cars, buses, and trains at the time. No one questioned the design. After all, it had worked on the ground. But in the air, something was different, something deadly. Within a few short years, 3 Comet jets broke apart mid-air during normal flight. There were no signs of mechanical failure, no reports of weather issues. The planes simply disintegrated. Investigators were stunned. What could cause a brand new, state-of-the-art aircraft to tear itself apart? To find the answer, engineers took the wreckage and rebuilt part of the fuselage. They placed it inside a massive water tank and began pressurization tests, simulating flight stress. Eventually, the weak point revealed itself. The windows. More specifically, the sharp corners of the square windows. Here's the science behind it. At 30,000 feet, the air pressure outside is incredibly low. To keep passengers safe, the inside of the cabin is pressurized. Every time a plane takes off and lands, the fuselage expands and contracts slightly. It's like blowing up a balloon over and over again. Now, square windows have sharp corners, and corners in engineering are natural stress concentrators. Every flight cycle added microscopic cracks. Over time, those cracks grew until the plane gave out mid-air. It's a phenomenon known as metal fatigue, and in the 1950s, it wasn't well understood. After this discovery, the solution was simple but life-saving. Engineers redesigned aircraft windows to be rounded or oval. This allowed pressure to distribute more evenly, with no corners to trap stress. A small shape change saved thousands of lives. Since then, every commercial airplane has followed this rule. Round windows became the standard, and the tragedies of the past became lessons for the future. Now you might be wondering something else. Why are airplane windows so small? It's not just about shape, it's about size. Larger windows create larger stress zones. And while big windows might offer better views, they also weaken the plane's structural integrity. By keeping them small and round, engineers balance safety, comfort, and efficiency. Here's a fun fact. Many airplane windows also have tiny holes at the bottom. They're called bleed holes, and they help regulate air pressure between the inner and outer window panes. They also prevent fogging and cracking due to temperature changes. So yes, even the little hole has a big purpose. What looks like a basic design is actually the result of decades of trial, tragedy, and innovation. The next time you're on a flight looking out through that curved window, remember, you're not just seeing clouds, you're seeing a story, a reminder of past mistakes, and proof that sometimes the smallest details make the biggest difference. If you found this story fascinating, subscribe for more simple explanations of the everyday world, one mystery at a time.